Hello Stormwater designers, welcome back to Clear Creek Solutions hydrology education videos, and today we're going to be going over groundwater wells. We kind of touched on groundwater in a previous episode, but now we're going to go more in depth on what wells are, the different kinds, and how they are constructed. So quick introduction. A well is an excavated hole, usually a vertical shaft in the earth allowing access to groundwater, which we discussed earlier. Wells are constructed for a variety of purposes, including extracting groundwater from municipal water supply. Depending on the purpose of the well and the geologic environment, it may be dug by hand, driven and bored, or drilled by a drilling rig. The simplest type of well is the dug well, consisting of a pit dug to and a little below the water table. So you can see here another diagram of aquifer, a groundwater flow, and then a well, going into that supply there, just below the cone of depression in this case. So that's what the well is doing. That's its area of influence. And so driven wells up to 4 inches or 10 centimeters in diameter and 60 feet 20 meters deep may be constructed in unconsolidated materials by use of well points. A well point is a section of perforated pipe or well screen with its lower end pointed for driving into soil. It may be driven with a maul, weighted pipe, or power hammer. Additional sections of plain pipe are connected to the well point by threading couplings until the required depth is reached. Because of the limitations on size and depth, driven wells are not ordinarily adapted for large water supply projects unless employed in large numbers. Earth augers are used to construct bored wells in unconsolidated material. The 3 most common types of bucket augers, solid stem augers, and hollow stem augers. All 3 excavate material with cutting blades at the end of a drill rod or pipe. Bucket augers collect the excavated material in a cylindrical bucket to which cutting blades are attached. When full, the bucket must be lifted from the hole dump. Solid stem and hollow stem augers lift the cuttings from the bottom of the hole to the surface using a spiral flange called flighting. So you can see here's a single stage point well. We've got the head, the jetting holes, inflow pipe covered with a filtering screen, and then the riser, and then finally the header with the sand and gravel filter. A common method of well drilling is the use of the cable tool rig. A heavy bit suspended on a cable is raised and lowered in the well, crushing the material at the bottom. Large deep wells are typically constructed by the rotary method. In this method, a bit is rotated at the end of a string pipe. A drilling fluid is continuously circulated through the borehole to bring material loosened by the bit to the surface. The most common drilling fluids are mud slurries and compressed air. In direct rotary drilling, the fluid is pumped down through the drill pipe. It returns to the surface through the annular space between the pipe and the walls of the borehole. And then real quick here's some well equations that are used for calculations on different exams and such. So we have a well drawdown calculation for unconfined aquifers. So you have the different radiuses, the permeable soil in the bottom of the aquifer, and then the height of the different aquifers there. We have Dupuis formula, which calculates flow rate of the water drawn from the well here, given a p-metric head. And then we have the Thiam equation, where transmissivity is used for those calculations there. So that's some well equations. That's a quick overview of wells. If you have any questions, you can ask in a comment down below. Otherwise, we have the hydrology terms guide for you. It's a cheat sheet, 4 pages of hydrology terms. If you're studying for a test or you just want to brush up on your terms, you can download that for 100% free. Anyways, we'll see you guys in the next video.